Huh. That was weird. So right now, today, what we're working on hyperbola. So right here, I'm going to write the last conic section. Okay? A hyperbola is created when you take a plane and it intersects with cones. And you'll notice right here, this is the cross section of the cone. Now, a hyperbola can either go left and right, or it can go up and down. So that's what you're going to be working with when we're dealing with hyperbolas. Either it's going to be going to the left or to the right, or up and down. Notice, when it's opening left and right, what leads out? The x values. When it's opening up or down, what leads out? The y values. Now, something you're going to notice when we're working on these is the only difference between the formula for an ellipse and a hyperbola is one thing. There's only one thing that's different. You guys see this formula right here? Or this equation? The only difference is, if I put a plus right here, what does that change it to? An ellipse. If there's a plus, it's an ellipse. If there's a minus, it's hyperbola. So what exactly is a hyperbola? I'm going to come over here. I'm going to zoom in.
So basically, it's the same thing as an ellipse, except it's like...
I mean, the equations look... Yeah, the equations look pretty much exactly the same. Now, this right here is the definition of a hyperbola, all right? We have two foci right here. And what do you guys notice? What do you think it's telling us through this dotted line from here to here, and this dotted line from here to right there? What do you guys think the distance is from F2 to Q and from F1 to P? What do you think about those distances? What do you think? They're equal to each other. So this right here is the definition of a hyperbola. It says it's the set of all points in the plane in which the difference of the distances from the 2 points, called the foci, is constant. So right here, it says P to F1 minus P to F2 is going to equal Q to F1 minus Q to F2. So the differences are going to be equivalent to each other. So let's scroll over here. The differences are going to be equivalent. Okay? Not the sum, but the differences. All right. There's a lot of stuff going on right here. So if you're watching this video, you might want to pause it and jot all of this down. All right, I realize there's a lot going on right here. The very first thing I want you to pay attention to is this point right here. Okay? That point is the center of your hyperbola. So where you have the word center, I want you to write H, comma, K. That is going to be important information for using either one of the two equations, all right? When I say one of the two equations, it's talking about you're either using this equation or you're using this equation. Okay? Now, the other piece of information that you would need to know, you need to know this distance right here. And that distance is called your A value. And you also need to know the distance from here going up, also going down. And that's your B value. If you know A, B, and H and K, then you have all the information that you need to make your equation for your hyperbola. Okay? The asymptotes are very useful, all right, in being able to draw your boundaries. Okay? Two different words that are different than an ellipse. We do not have a major axis and a minor axis. We have what's called a transverse axis. And you have what's called the conjugate axis. Now, in the major and the minor axis, the major axis is always the longer one, the minor axis is always the shorter one. In hyperbolas, that's not the same distinction. A can be shorter than B. Okay? So, just because A happens to be the longest here, it doesn't always have to be the longest. Now, I want you to notice, so both sides, what always passes through the foci. Which axis? The transverse. So if I gave you the transverse axis, know that the transverse axis always passes through the foci. Okay? What I want us to do right now is I want us to look at problem number 3. So we're going to go over here to problem number 3. And you'll notice that this hyperbola opens to the right and it opens to the left. So here's what I want you to do on your paper. I want you to use the very first equation, which is x minus h squared over a squared minus y minus k squared over b squared equals 1. All we're going to do in problem number 3 is we're going to identify h and k, and we're going to identify a and b. That's all we're going to do. So the very first thing I want you to write down is I want you to write center. And you're going to identify the h and the k value. The center is always where the two asymptotes intersect. You'll notice the asymptotes are drawn in for you, so there's my center. From the origin, it looks like it goes over 1 and down 2, so just write 1 and a negative 2. Now, the next thing we're going to build is we're going to build the rectangle that you're going to need for the drawing. So I want you to notice, from the center, it goes over 2 to the left, and it goes over 2 to the right. I want you to label these. You don't need it for this particular problem, but I want you to label it. This right here is a vertex, and this right here is also a vertex. That's important. So you always want to start from the center going towards your vertex. Then, from there, what I want you to do is I want you, from that point, to travel up until you reach one of the asymptotes. You hit the asymptote right there, put a point. From there, go across until you find the other asymptote. Put a point. Now start going down through the vertex until you reach the other asymptote. Put a point right there. And last but not least, keep moving to the left. Put a point. Now, what I'd like you to do right now is I would like you to carefully draw in this rectangle on your paper. Draw in that rectangle right there on your paper. I'm going to put 2 different colors right here, okay? So you guys can see that I've not changed the center point. The center point is still right there. The vertices are still right here and right here. I want you to understand, from the center to right there, or from the center to right there on that vertex, that is your A value. So my A value in this particular hyperbola is 2. The distance from here all the way up, how many units does it go up, or how many units does it go down? 3. That's your B value. So this is the B value right here. Now remember when I said A is not always going to be bigger than B. A is always bigger than B when you're dealing with an ellipse. It's not always the case when you're dealing with a hyperbola. So now we have all of the information that we need to be able to what? Write our equation. So here we go. Here's your final answer. X minus, what's our H value? 1. X minus 1, and we squared over. What is our A value squared? 4. And you put minus. Y minus, what's our K value? Negative 2, right? So if I plug in a negative 2 right there, what's going to happen? We're not going to put minus and minus. What are we going to do? Yeah. Just change it. Just put a plus. And then square it over our B value squared. What's our B value squared? 3 squared, which is? And then you say equals a 1. You're done. So what's the only thing that you really need to be able to identify in a hyperbola? Identify your H and your K, your A value and your B value, and you should be able to do what? Write your equation. Why don't you guys go ahead and try to do number 4, and we'll check it here shortly. All right, let's see how you did. Here we go. We'll go ahead and zoom in a little bit more. All right, predict what I'm going to do. What's the very first thing you think I'm going to do? Yes, find the center, where the two asymptotes cross. It's a word. It's a math word. Asymptote. Say it. Chicken. Yeah, say it. That's right. Those are asymptotes. That's what they are. Just what you call them. Call them like you see. What's your H and your K value? 1 and 3. Got it. By the way, do you see how the hyperbola opens left and right? That means we once again use the very first equation. Alright, so there's our equation. Now, from there, I need to go over to the left and put a point here, over to the right, put a point there. From there, I travel up until I reach an asymptote, and go over, and go down, and down once again. And what am I going to build, everybody? I'm going to build my rectangle that provides me the boundaries that I need to make a nice hyperbola. Okay. So how far do we go from here and here? Just 1 unit, right? Now what does that 1 unit represent? Our A value. It's our A value. Our A value is equal to 1. So not only is it a wonderful steak sauce, but it's equal to 1. Now, how far do we go up and how far do we go down? 2. And what does that 2 represent? That's right, that's our value for B. So now we're done. We say x minus our h value, which is a 1. We take our a value, and what do? We square it. 1 times 1 is 1, so we keep it there. Minus y minus our k value, which is a 3. Over b value, which is squared, which becomes a 4 equals 1. Pretty easy, huh? Not too hard. Now, just remember, what is this point right here called and that point right there called? Those are the vertices, okay? We have 2 of them, okay? Now it's time to do something difficult. Right now, what I need you guys to do is put problem number 1 in your journal. Just write down the equation, just like that, because we have to complete the square. So write down problem number 1 in your journal exactly as it appears. X squared minus 4y squared minus 4x plus 24y's minus 36 equals a whole lot of that. That's what I need you guys to put into your journal. So we need to know how to complete the square so we can build. We're trying to build an equation out of this. So the first thing you do, I know it's going to be a little awkward, but right now I need you guys to get all of your x's together right here. Alright? You're going to put an empty space. Now we're going to get all our y values together. We have a minus 4y squared plus a 24y plus, I'm going to put a square right there. Now the only thing that you're going to not see me do is you're not going to see me add 36 to both sides, because I like to just throw numbers across equal signs. Makes me happy. Just saves me a step. Just remember, anytime you move a number across an equal sign, what happens to it? It becomes the opposite. That's it. You won't see that in a math textbook, okay? You won't see the throw it across the equal sign method. Right? People might frown upon you if you do that. You'll see this. You need to use the additive inverse to both sides. Right? There are some algebra teachers that say, I don't subtract, I always use the additive inverse. Those are called algebra snobs. I don't care if you're an algebra snob, that's fine. Go ahead, be an algebra snob. Now, What we have to do, guys, is we have to complete this square, and we have to complete this square. Which one is the easiest one to complete the square? The blue or the red? The blue. So, that -4, that represents your b value in the quadratic equation. Now, if you're wondering what the heck is a quadratic equation, typically you see a quadratic equation as ax squared plus bx plus c. That's what you typically see. Okay? So I'm going to erase that. What is this value? This is my c value. When you're completing the square, what is the c value always equal to? B divided by 2 squared. Or you take half of b and you square. Take half your b value and your square. What's half of that? -2. What's -2 times -2? 4. You put a 4. If you put a 4 over here, what you got to do right over there? Put a 4 over here. So that was the easy one. So I'm going to highlight that. Because we need to know how to factor this. This is easily factorable. What does that factor to? Because a -2 plus a -2 is a -4, and a -2 times a -2 is a positive. If you use the FOIL method, it will still work out. That's just a short. Unfortunately, this one right here is not as easy. What am I going to have to factor out first? -4. So we're going to factor out the -4, everybody. We're going to say minus a 4. We're going to open up a big old parentheses right here, and watch. I'm going to take everything right here, and I'm going to divide it by a -4. So this -4 cancels out this -4, and all I have left with is a y squared. I have a 24y. I divided by a -4, and that leaves me with a -6y. Then I drop this down right there. I'll put the equal sign. I'll put the 36, just like I have it. I'll put my 4 right there. And I'm going to move it over just a little bit more. Put another box right there. Okay. The only way you can complete the square is if you factor out the number first. This right here has to have a 1 right there, a 1y squared. So now I'm going to draw an arrow. That's my new b value. This is still my c value. So I'm still going to take half the b value, and I'm going to square it. You got it. That's a 9. Now this is where students will make a mistake. They'll get this part. They got half of -6, which is -3. -3 times -3 is positive 9. But here's what they'll forget. They'll forget that this 9 is actually being multiplied by a -4. So I'm not allowed to just put a 9 right here. What do I have to put right here in this? -3. So a -4 times the 9 gets me that -36. Now I've completed the square. This is a perfect square trinomial, just like this is a perfect square trinomial. Although if you don't know what a perfect square trinomial is, just Google perfect square trinomial. Maybe go to the Khan Academy, watch him. He's brilliant. Way more brilliant than me. Okay. What does this factor to? Y minus 3 squared. Because -3 plus -3 is a -6, and -3 times -3 is a positive 9. We're almost done. This is all equal. So x minus 2 squared minus 4 times the difference of y and y minus 3 squared is equal to, let's go over here. Oh man, what happened to that 36 and that -36? They battled it out. They both died. What's the only number that's was left standing? Or because he didn't have a conflict with anybody. He just bring them down right here. Alright. So we've completed this square. We've completed this square. So all we have left to do is just to divide every single number by 4. And here's your equation. X minus 2 squared over 4 minus y minus 3 3 squared. This is where you guys need to remember. These 4's will cancel each other out. But don't forget, it's technically over a 1. That's where the minus comes in. Okay? And what is that all equal to? That's just equal to 1. This is your equation for problem number 1. Now we're going to take that equation tomorrow. We're going to take that equation and we're going to find all of the pieces of it. We're going to find both sides. We're going to find the vertices, okay? We're going to find the equations to the asymptotes. But what I'd like you guys to do right now is at least just draw. Let's just draw it right now. What's our center? What's our H and our K? What's our center? 2 and 3. What's our A value equal to? Just a 2. What's our B value equal to? 1. So let's go ahead and just draw. It won't take that long. Here we go. We're going to take this right here and we're going to draw. All the way up here. We're going to go over 2 and up 3 and put a point. What's that point called? That's your center point. What was our A value? That's right, 2. So go over 2, put a point. Go to the left 2. Put a point. Your B value was 1. Put a point here. Put a point here. Now, here's what I need you to do. Carefully. Draw your rectangle around those, okay? Draw your rectangle with me right here. We're going to go ahead and draw in some asymptotes. From the center point, we go up 1 over 2, up 1 over 2, up 1 over 2, keep going up 1 over 2. I'm also going to go down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2. There's one of my asymptotes. Oh! Right there. Here's my other asymptote. From the center point, going down 1 over 2, 2, 2, 2. Aha! There are my asymptotes. This point right here is a vertex. This point right here is also a vertex. From here, just get your hyperbola close to that asymptote, but do not cross it. Trust me, you do not want to cross an asymptote. They're not kind. You don't want to be one in life or in math. But don't you want to be when you grow up in life and in math? You don't want to be an asymptote because people don't want to get near you. Now, how did I know it was going to open left and right? How did I know it was going to open left and right? Because my x values right here are positive and my y values are negative. That's how I know it's going to open this way and this way. We'll see y'all tomorrow.